Now let us look at how we can add two polynomials and generate a third polynomial. I have two polynomials here, P1, this is the polynomial and its representation. P2, this is the polynomial and this is its representation. So already I have taken those terms here. Now by adding these two, we want to get this one. So actually we want to add these two polynomials, but our program is having this representation. So it should add these two and get the third representation. Now let us see how to add. So the first thing is total how many terms will be there in this third polynomial. How many terms here? 3. How many terms here? 5. So common terms with common power terms will be added. If nothing is common, then maximum how many terms will be there? 3 plus 5, 8 terms will be there. Maximum 8 terms are possible. If some terms are common power, then they will be added. So number of terms may be less than or equal to 8. So anyway, that I can know only after adding. So I need an array here of size. How much size? Again, maximum 8. So I should take an array of size 8 here, but I already know what will be the answer. So I have taken only 5 here. So you have to take an array equal to the number of terms here plus number of terms here, because maximum that many terms are possible. Now let us see how to add these two. So for adding these two, we need pointer, index pointer, right? Not an address pointer. I on 0 of this one, j on 0 of this one, and k on 0 of this. Like when you add these two polynomials, first term is x power 4. This is also x power 4. So these two will be added. So here, what is the exponent? 4. What is the exponent? 4. So these two exponents are same, powers are same. So add these coefficients. 5 plus 6, 11. So this is 11 and the power is 4. So now the terms are added. So move I to next term, move j to next term, and move k also to next term. Then continue the same thing. Check power 2, check power 3. No, that power is 3. So this polynomial is not having any term with power 3. This is having a term with power 3. So that is greater. So take that one. So it means if the power of this term is greater, then copy this one. If the power of this term is greater, then copy this one. If the powers are equal, then add their coefficients. This is the procedure. So now this power is greater. So copy simply 5, 3, move j to next term and move k to next term. Compare powers. They are equal. They are equal. So add the coefficients and take the term. So what are the coefficients? 2 and 9. So this is 11 and this is 2. Then when we have added, we should move in both. I is also moved, j is also moved, and k is also moved. Then again check the power. This is 0, exponent 0. Power is 1. So that is greater. Copy that one. 2, 1. Move j. Move k. Now check powers. Both are equal. 0, 0. Then add coefficients. 5 plus 3, 8. 8, 0. That's all. They are added. Then let us write a piece of code for doing this one. I is initially 0. J is also 0. And k is also 0. All are starting from 0. Then we don't know total how many terms we get. So we can't use for. If we know the number of terms, then we can say for these many terms. So we don't know. We have to use while loop. While. How long? Until I reaches this one, means less than n. P1's n. And j reaches this one, that is P2's n. I is less than P1 dot n and j is less than P2 dot n. So if any one of them finishes, then we should stop. And while iterating through these, we should compare them. Whoever's power is greater, copy that one. If This is power we have to see, exponent. So P1's t is of i's exponent. So if I is here, then P1's t of i's exponent. So if P1's t of i's exponent is greater than P2's t of, like j was starting from here, j dot exponent, P2's t j dot exponent. If this is greater than that one, means this is greater than this one, if suppose, then copy this one as it is in P3's t of k. So P3's t of k plus plus also. Afterwards we should move k. Assign with P1 dot t of I plus plus also. Here also after copying we should move I. See, for copying I should copy coefficient and exponent. But I am not saying dot coefficient or dot exponent. We don't have to. Both the values will be copied. When you are assigning a structure to another structure, all the members will be copied in C language. So you don't have to worry about copying each and every one individually. So it will be copied. If this was greater, we copied this one. If that one is greater, we'll copy that one. So I should write on the condition here, else if P2 dot t of j's exponent is greater than P1's t of I dot exponent, if that one is greater, then copy this term in this one. So just like same statement, instead of P1 I should say P2 and j plus plus. So here I have written, that is in P3 of t of k plus plus, copy P2 dot t of j plus plus. So this term will be copied here. The last thing, final else. Else what we should do? So in final else means both are equal. Both are equal means exponent should be taken as it is, but coefficients must be added, like 5 plus 6 we were adding. So coefficients must be added. So I should prepare two terms of this one, exponent and coefficient. So let me write on this one. So I have to write two statements here. So P3 dot t of k dot exponent, I can copy this exponent from here also or from here also, either P1 or P2. So I will write P1's, P1 dot t of I dot exponent. So this is one statement. So I will use lower bracket. So this is copied. Then coefficients I should add them. So P3 dot t of k plus plus dot coefficient should be equal to P1's t of I plus plus dot coefficient plus, there is no space, so I will continue in the next line, plus P2 dot t of j plus plus dot coefficient. So in P of tk of coefficient, I am adding coefficient of P1 and P2. Two coefficients I am adding. So here I have explained with example and also how the program code should look like. I have written the code also. So this code we will use it in the program. So that's all about polynomials and the representation. Then we will see the complete program on polynomials.